Welcome back to ReddyControls YouTube channel. In this video we continue our Mastering PLC Programming Industrial Automation series. We are coming with part 3. We completed part 2 of the series where we completed all the IO mapping and tested all the IO mapping. The link to the video will appear on the top right side. Here just a rewind of the previous video. Here is the layout of our conveyor belt. The conveyor belt has one motor and two gravity conveyors and operator station, and this is the photo eye at the operator station. And the conveyor belt also has a weigh scale. When a box is at the operator station, the box indexes to the weigh scale. Depending on the weight being in tolerance, the box will go to the good conveyor. If it's out of tolerance, it will go to the bad conveyor. And these are all the photo eyes which we have. Photo eyes 1 through 6, and then we have two diverters, diverter 1 and 2. Diverter 1 is for kicking the boxes to the good conveyor. Diverter 2 is to kick the boxes to the bad conveyor. And we went through last time and mapped all the IO. Based on this one, we downloaded the PLC program and did an IO check. And in this video we're going to build the logic. For the logic, we're going to use something called a sequencer logic using move instructions and equal to instructions. So we'll go ahead and use this framework which we defined in the previous video and start programming. Now we will go back to the Studio 5000 Logix Designer environment. This is the IO mapping that we completed last week. Now we're going to develop the logic. Based on our sequence, the first step is step 0, where we are waiting on the machine to be in auto and cycle start. So for that step, we're going to check if the machine is in automatic mode, and whenever we push a cycle start button, that's when we move the machine into step 10. And in step 10 we check to ensure there are no boxes on the conveyor, and once that condition is on, we'll go into step 20. And in step 20 we make sure there are no boxes. Once we verify there are no boxes on the conveyor, we're going to check in step 20 that both the diverters are at home position. And once we know, the reason why we want to check the diverters are in home position is to prevent any jam ups. And then in step 30, once the diverters are in the retracted position, we go into step 30, and now we are waiting for a box to appear at the operator station. And once the box is present, we will turn the motor M1, which will move the conveyor belt, and the box will now index to the next station, which is at the weigh station. So in step 30 we wait for the box to appear at the weigh station, and once the box is at the weigh station, we move into step 50. And in step 50 we're going to wait for the signal from the weigh scale, depending on a good signal or a bad signal. If it's a good signal, we go to step 60. If it's a bad signal, that's saying weight is not okay, we move to step 80. And then once we are in step 60, we're going to make sure the box is kicked, or using the diverter, we extend the diverter and push the box into the good conveyor. And we go into step 70. After we kick the diverter, we go into step 70 and wait for the box to appear on the good conveyor. And once the box appeared, we go back to step 0. So, and this cycle repeats as long as the machine conditions are met for in auto and cycle start. So we'll go back into the Studio 5000 environment and start coding this. As we said, the first and foremost step is making sure the machine is in auto and getting a conveyor OK signal, right? So we'll go ahead and insert a new rung. So we already know there is a cycle start push button. Once the cycle start push button is pushed and stop button is not pressed, and we already discussed in the previous video the machine safety conditions should all be okay. Once the safeties are okay, we will go ahead and give a conveyor underscore okay run signal. We'll go ahead and create that new run bool. So these are all the conditions for the conveyor to run. But since the start push button is a momentary push button, we push that and the condition is only on as long as we hold it, right? So we need to come up with some kind of a seal-in condition to seal the start push button. So what we will do is we'll add a branch around this. We went to the add-on instruction and then add-on toolbar, selected the branch, put that and extend it. So we want a branch around the momentary start push button. We will use examine on of the conveyor okay run. Okay, so all we created when the PLC is scanning it, it is checking for the start push button. Once the push button is high, it will go through. Stop button is not pressed and the safeties are okay. We will make the conveyor okay run, and in the next scan when it comes back, conveyor okay run is still high, so it will seal the start push button. That way the start push button does not need to be holded on for a long time. Okay, so this concept is called as seal-in logic. We are not using any latches or unlatches, we are using a seal-in logic. So this is nothing but considered as a seal-in logic. So now we know the machine. We'll go ahead and insert one more rung. Now we take examine on. If the machine is okay to run and the machine is in auto, as we discussed in the previous video, in auto is a momentary bit that we had to create. Since we don't have any selector switches, we will go ahead and create a momentary, like a simulated input button, which we had to toggle, and we call it as a in auto. Once all the conditions are met and the machine is in auto, we want to go ahead and make a auto underscore cycle underscore start bit. Okay, and now for the rest of the logic we'll just use this one, auto cycle start, right? So based on our sequencer file, we said the first step, in step 0, we want to make sure all our preconditions are met, right? So we will go ahead and code that piece of the logic. So in step 0, by default we use step 0 as the initial step, and we'll come back and show you how to do the how the reset logic works. So the way how we're going to do this is we go ahead and do compare, do EQ. I'm using version 36. In version 36 it's EQ, it's no longer EQU as in the previous one. So we'll go ahead and drop that here, EQ. We will create a new tag called sequencer step, and we make it a integer. Create, and all this does is we'll go ahead and put a description on that. Sequencer step holds the sequence step number of the machine. Okay, So all that one is this number, the sequence number. Okay, so we will say when sequencer is in step 0 and auto cycle conditions are met, that's what we are checking in step 0. We want to check to make sure auto cycle conditions are met. When auto cycle conditions are met, which is auto cycle start, we will index the sequencer into, so we'll index the sequencer into step 20. So when we say index the sequencer into step 20, all we mean is why we just do a move instruction, MOVE move. Again, this is a change in version 36. Earlier it was just a MOV instruction, but now they kind of, Studio 5000 now clearly calls it as a MOVE move. We will move 20 into sequence step. So that's how a transition from step 10, right? That's how a transition from 0 to 10 happens. That's how we write the logic when it comes to sequencers. In order to cut down the time of the video, I will go ahead and demonstrate the complete logic on a previously running video. So the same thing, we did the ceiling condition when we created auto cycle start, and once the sequence step is in 0 and auto cycle start is on, we index the machine into step 10, and once we are in step 10, our condition was there are no boxes on the conveyor. How do we know there are no boxes on the conveyor? Is when we check all the status of the photo eyes to be unblocked, right? All PE1 through PE6. So all we are doing is we are in auto cycle start, we are already in step 10, and we checking for all the photo eyes to be unblocked. As you can see, at operator station, weigh station, diverter 1, diverter 2, good conveyor and bad conveyor. Once these conditions are met, we move the sequencer to step 20. So when you're troubleshooting it and the machine got stuck in step 10, you can just come to this logic and then troubleshoot if there is one of the photo eye being dirty or it's been blocked, right? So the aim of this program is to make troubleshooting easier, to minimize downtime on the machine. That's what the aim of PLC programming is to make it simple so that a maintenance technician can understand and troubleshoot. We'll continue. So now we are in step 20. Once we are in step 20, we're going to make sure our initial logic says, we'll just put this. Once we are in step 20, we need to check for all the diverters being at home position or they are retracted. We're doing that here by using not extended. Number 1 is extended. This will be in real world situation, this will be a reed switch that will indicate the position of the cylinder. So both the diverters are not extended. Then we move into step 30, and in step 30 again, based on our logic, once the box shows up at the operator station, there is no box on the weigh station, we're going to move into step 40, and once we are in step 40, we run the motor, so we expect the box to move, and operator station will not have a box, and the box will index to the weigh station. That's when we move into step 50. Once we are in step 50, there is no box, there is no another box at operator station 1. Box is now present at the weigh station. Now we are checking the signal of the weigh station. If the signal from the weigh station says weight is in tolerance, we move to step 60. If weight is not in tolerance, we move to step 80. Okay. That's where we are. The decision is happening in step 50 based on the signal from the weigh station. If it's good, we go to step 60, and then from step 60 we extend the diverter 1. The box goes into the good conveyors, and we go to step 70 and check for the photo eye of the good conveyors to be blocked. So that's all we are doing. Once we go into step 60, we write a condition. Hey, if the machine is in step 60 and the box shows up at and the box is at the diverter, move the sequencer into step 70, and once the sequencer is in step 70, we going to index the sequence, we're going to extend the diverter 1, push the box, and the box will show up onto the good conveyor. And once the box shows up on the good conveyor, we reset the sequencer to step 0, which will make the whole sequence to start back up. Okay. Similarly, if we get a once we are in step 50, we got weight not okay, we go into 80 directly, from 50 to 80, and in step 80 we ensure we check for the box to show up at the diverter 2, and then we move into 90, and once we are in step 90, the box at the bad conveyor, and wait for the box at the bad conveyor to show up in front of the photo eye, then we reset the sequence to 0. Based on our logic in these steps, step 60, 30, 60 or 80, the conveyor will be running, right? And then in step 70, we will, if the sequencer is in step 70, we will turn on the diverter 1 extend output, and if the sequencer is in step 90, we're going to turn the extend for the bad parts. The diverter 2 will be extended, and we route and we do an output mapping here. When we have good parts, we will turn on this output on the PLC. For us, that's the diverter output, and for bad parts is on, the logic bit is on here. Then we do an actual output, which is the red light on the trainer, and then when motor M1 is running, we'll have a green light on the trainer. So that's how we develop the logic. It will make more sense once we start simulating this program. See how this logic works in action. What you're seeing here is my Studio 5000 program, and the one which we were looking at. So we'll go ahead and explain this in action right now. So we'll go ahead and launch my Vision application using Vision Client Launcher. I have detailed a video how to map the tags. You could see that on the top right corner, link for that video on Ignition. So we'll go ahead and log in to launch the page, which displays the conveyor belt HMI application. As you can see, this is the conveyor belt HMI application we are talking about. We will stage it up so we can see both the logic and this one side by side. Okay, so we have the, let's make this even a little bit. Okay, so that's good enough size for the HMI. We will try to shrink it more. Okay. put it right there, put the logic here. Okay, so right now if we look at if you go to the HMI and look at the machine being in off status, you could look up in the logic and tell why the machine is in off status, because we don't have the start push button being pushed. Okay, that's one of the reasons. But if you look at this, step 30, waiting for box at operator station, where in step 30, so for whatever reason the whole sequence got out of sequence, so we'll go ahead and reset that. Typically we have some kind of a condition where you either push a button called reset sequence, and that will reset the whole sequence to step 0. We didn't have that here. We will go ahead and write that one logic, and we say somewhere over here we'll go ahead and add that one rung saying we'll create a simulated bit called reset sequence. I'll just call it and then whenever that's pushed, we go into insert, move, okay, 0 into our sequencer step. Okay, so that's just one way to reset this sequence. So we'll go ahead and toggle that. That will reset the sequencer to 0. So now the status here is saying, okay, I'm waiting on cycle start and auto, right? So the machine is waiting on cycle start and auto. That way when you troubleshoot, you can look up in the logic and say, okay, I'm waiting for a cycle start button, right? The safeties are okay, and I'm just waiting on the cycle start button. And we know the cycle start button is wired to the push button on the green push button on our trainer. So I will go ahead and push the cycle start button, and you should see the sequence. You should be able to see the conveyor OK run being high. So I'm pushing the cycle start button, and our seal-in logic kicked in, and we got conveyor OK to run, and we have now the machine is in auto, right? The machine is in auto. We got conveyor OK to run. The selector switch, in this case it's a toggle bit. We are in auto and we are in cycle start, right? So now the condition which we are waiting on, since we are equal to, we were in step 0, and once the auto cycle start was met, we moved at 10. The logic moved at 10 into the sequencer step. Now we are in sequencer step 10. That's what the display shows, sequencer step 10, waiting on all the photo eyes to be unblocked. And we come back to our logic and say, okay, we are in step 10. What condition indexes to go to execute this move? So you could see this rung in condition is true. Equal to 10, we are true. There is no box detected in front of station 1. There is nothing detected in front of station 1. There is no box in front of way station. But there is a box detected in front of the diverter, which is this blue box. And there is also a box detected on the good conveyor, but there is no box detected on diverter 2 and bad conveyor. Right, so whenever the photo eye is blocked, it's indicated with a value of 1, right? So the condition here I'm checking is for presence of no boxes or all the photo eyes being unblocked. That's why I'm using examine if closed instruction. That's the examine off instruction. Okay, so you have both examine on and examine off. So we are using an examine off. That means this value should be 0 for the condition to be true, right? So it's pretty evident we are waiting on these two things to be 0. Right now they are 1, and we wired them in our input logic. We wired them to the selector switch 3 right side. So I will go ahead and change the selector switch 3. Selector switch 3, which is in the right side, we're going to take it off, right? So now there is no box detected in front of the diverter, but there is still a box in front of the good conveyor, which is selector switch 4. We will go ahead and take that off. Now once that condition is met, you could see our green light is on. That is, we are in step 30, right? So we are in step 30 and the green light came on. Why did the green light come on? In our logic, we said the green light is an indication whenever the conveyor is running. And you could see this conveyor, earlier it was white color and the conveyor is now green, indicating the conveyor is running. And that's happening because all the way down in our output drivers, our motor M1 run came on, and our motor M1 run came on is on because of this logic. Whenever the sequencer step is in 30 or 60 or 80, we will ask the conveyor to run, right? Hope you are tracking good with me so far. So now we are in step 30. Now we were in step 20 and we indexed through, went into step 30 because none of the diverters are extended. We went into step 30. Now in step 30, we are waiting on a box to be present on the operator station. So in practical situation, there will be a photo eye wired to an actual input, but for now we are just using our selector switches. So the photo eye at operator station is selector switch 2. So I will go ahead and make selector switch 2. The moment I made selector switch 2, a box is present on the conveyor and the motor stopped running. And immediately once the box showed up and there is no box in front of the weigh station, we moved into step 40. Once in step 40, there are two conditions for the box. There are two conditions to go into the next step, which is no box present at the operator station. So we will mimic again, we'll switch selector switch 2, and then now selector switch 2, and then we will use selector switch 3 left position to mimic a box present on the weigh station, and we immediately jump to step 80. Why did we go to step 80? So we were in 50. When we were in 50, and when we were in 50, we had wait not okay. So that's what made us go to step 80. Okay, so we go to step 80. Once we are in step 80, that box has to be diverted. So we will simulate the diverter using selector switch 4 left and the diverter extended. You could see the diverter extended. Now we are waiting on the box to come back to photo eye 6, which would be a toggle bit. Oh, sorry, what is this? OTA for that is a photo eye 6 input, so we'll go ahead and toggle that. Now the box showed up and we are back to step 10. We went to step 0, and since we are in auto, cycle start, we moved into step 10, but we are not indexing anywhere because there are still boxes on the conveyor. That's one of our start condition, is there are no boxes on the conveyor. Okay. So what we're going to do now, a different cycle where we will go ahead and toggle, see this wait OK bit, we will go ahead and put selector switch 1. So we have always wait OK. And now I need to clear the conveyor, remove all the cases from the boxes, we need to remove all the boxes from the conveyor, so we'll go ahead and use our selector switch 2 and selector switch 3, and we have selector switch 4 and photo I6. Alright. So now the conveyor is empty and there is a box present. We are in step 10. So we need to go ahead and remove that box from conveyor at operator zone 1. So we will put the selector switch 2 in off condition. That's it. So now the machine is reset. We are in auto. I will place a box in front of the operator station using selector switch. Once we do that, we automatically went to step 40 because of our wait. We went into 40 because both this the step 30 was, since all the photo eyes are good, we went to 20. From 20 we went to 30, and in 30 we are waiting for box to be present at the operator station and box not to be present in the way station. We move to 40, and once we are in 40, the condition to move the box is we remove the box, do that, and we place the box in front of the way station. Since wait OK signal was already high, we went directly to step 60. We are in 50, we went to 60. And once we are in 60, we are waiting for the box to show up in front of the diverter, which we're going to do with that. The diverter extended. Now we are waiting on the box to show up on the good conveyor, which would be, good conveyor would be right, and now we are in step 10, but we cannot start step 10. The box showed up on the good conveyor and the downstream process will take it away. So we'll go ahead and reset the box present at good conveyor. So somebody picked up the box and now the cycle is reset back to waiting for box at operator station. So that's how we that's how this program works. Hope I was able to give you some understanding of how simple it is to use a sequencer using equal to conditions and move condition. There is nothing complicated in this logic. It just looks intimidating to begin with, but once you get used to writing logic like this, our main intention is to have a code or have a PLC program which is easy to troubleshoot. If the maintenance person can troubleshoot in the middle of the night and can bring the machine back up and running, that's the best scenario we have. So again, if you have any questions, please post them in the comments. But other than that, continue learning, practice, and I will see you in the next video. Thank you. Bye.